Okay, welcome everyone to Prysmatic Labs core meeting number 3. It's great to have you all here, and we have a lot to talk about today. We'll be discussing the things that are on our meeting agenda, which has been shared over our Gitter channel and will be shared over the chat transcript and also the YouTube video description. But today we have a lot to talk about. So does anyone here have anything they want to share before we begin the meeting? Otherwise, we will start right away on the meeting minutes. All right. So cool. So let's begin. So a lot has happened recently. There have been a lot of changes to the phase 1 spec, and essentially, where we were before has now changed in terms of our focus and what we should be working on. And this meeting is mostly to get everyone on the same page and ensure that there won't be any more breaking changes in how we approach our coding sprints, to the point where we all know where we are. So Preston, do you want to kick things off with kind of what happened at the internal sharding meetup?
Yeah, so a couple of us went out to Taiwan to meet with the core researchers and sort of get a real-time Q&A and 3 days of long sessions talking about, what phase 1 spec is now and some of the reasons that it is the way it is. And then most of the time we spent talking about future phases and kind of elaborating what we know and what we don't know. So there's a whole lot there. It's kind of out of scope for this meeting, but I think we're going to be putting together. I'll also be putting together our notes in the coming days, and then we'll share that with the team. But there definitely was a lot of content there.
Cool. I can give a brief overview of the content that we discussed. So can you guys see my screen, by the way?
Yep.
Yeah.
Yep.
Cool. Yes. So essentially, where we were before with Prysmatic is that we were attempting to implement the phase 1 spec from the sharding README and the sharding FAQ that Vitalik and some of the Ethereum Foundation had put together a while back. And the original phase 1 spec was the original idea of managing something called validators through a sharding manager contract, where people would stake Ether into a contract and then would get selected at random intervals of time to propose transactions into shards, right? The key problem with this approach was that these individuals, known as validators in the old spec, would be responsible for a massive amount of computation and open up the possibility of creating 1% attacks on the shard chains. The idea is that we want validators to be reshuffled across shards as frequently as possible. We don't want anyone to be able to know what shard they will be assigned to in advance. So a neat abstraction that the research team put together was to separate the whole proposing of collations and the consensus layer. So we're going to have nodes called proposers that will be tasked with packaging transactions into blobs and into collations. And we're going to have collators, which are the people that in the old spec were referred as validators, but are the people that are going to be staking Ether and reaching consensus on the valid canonical shard chains. All of this is detailed in the ETH research post, specifying the new glossary changes. So one of the things I want to highlight is that this glossary is super important for us to adhere to and to stick and to just work with as we move forward. We have to be really careful with how we use our terms, especially over our Gitter channel and when we discuss any of this through the forums or with each other. There are lots of changes that are different from what we had in the previous documentation spec that's actually still live on the Prysmatic Labs repo. So one of the things that I've been working on is changing the documentation. I have a bunch of commits that I will be pushing up after the meeting, where I modified our old README to align with this new spec. One of the important things that I want to talk to you guys about is specifically what's going to change. And what's going to change is that so we have collators and we have proposers, but nobody here in phase 1 is actually in charge of state execution. So we're not going to have an EVM. We're not going to have any EVM changes. We're not going to have any sort of people that are going to be validating transactions in the traditional sense of the word. In this new spec, proposers will basically blindly process transactions into collations that have a 1 megabyte fixed size, and they will then be kind of giving these proposals of collations to collators and these collators will accept the ones that offer them the highest payout. Right? Like Preston said, the details of this are kind of beyond the scope of the meeting, but they will be updated in the current README that we have on our repo. It'll explain everything about kind of how phase one will be done through proposals and collator separation and crypto economic incentives. So yeah, the key takeaway is that we will have no state execution on phase one. We will not be considering any state transition functions, any EVM changes. We will not even be running transactions on a local node. So essentially for phase one, we can literally package, trash data into collations and it wouldn't really matter. Because the key thing about phase one is we just want to iron out the whole proposal collator interaction and figure out like an effective crypto economic incentive mechanism for them to interact and to reach consensus on shard chains. So great. So that is essentially the main takeaway of our implementation, and that actually simplifies a whole lot of what we're working on, especially because the way we structured this was that we planned on having state execution. But now we can simplify things by just focusing on packaging transactions into collations and like offering them to collators that are active on the current shard, right? And we'll be discussing this more throughout the meeting, but that's just the main takeaway that we got. Aside from that, I also want to go over the roadmap for Prysmatic and the roadmap for every sharding implementation out there. Keep in mind that this is very, very, very early stage in research, and the later phases are fuzzier and harder to understand. So to recap, the official sharding glossary mentions that phase one will contain basic sharding without the EVM. We'll be packaging transactions into collations, known as, we will be referring to these packaged transactions as blobs, because they're essentially just blobs of useless data until we have state execution. We're going to have proposers, we're going to have proposal commitments, which is a whole incentive game that proposers and collators play with each other. And we're going to have collation availability challenges, which we will discuss a little bit later on, because that was an important point of discussion. Outside of that, let's just briefly go over the future phases so that everyone on the team is on the same page. So for phase two, which is going to be basically the Sapphire release for Prysmatic, and for those that are unfamiliar, the releases for Prysmatic are outlined in our README, but that's when we would be focusing on state execution, coming up with different abstractions over accounts, cross-contract calls and such. For phase three, we're focusing on light clients, which is a whole beast of its own. Introduces a lot of security considerations that they're just really, really important for us to proceed.
Question about phase two. You said it would be beyond the Ruby release. So from what I recall, we scoped these things in terms of how far in the network they'll be running. So does that mean it'll be running on a testnet, or are we still considering this local implementation, but including things like peer-to-peer and alternative execution engines and executing in general?
Good point. So to answer Preston's question, there is still a lot of uncertainty about the P2P networking aspect of things. I know that you guys posted something over the Gitter chat. I know that Nishant has been working on that, so super thankful for that, Nishant. I think that there is a lot to consider with respect to that, and that's a whole project of its own. And actually, we were discussing this with Preston, that for phase one and for our local testnet implementation, we don't really need P2P because it's going to be running on a local computer. So the way we're going to do phase one is through kind of a file system interaction. So people are going to interact by saving collations into files, and then collators will be fetching those collation headers from those files and basically kind of mock up like their interaction without relying on coming up with a peer-to-peer framework. So I think we're scoping things in terms of local testnet implementations. Especially for phase one, we just want to get something that works on people's computers right off the bat. For phase two, I think that we can definitely also scope that in terms of a local testnet implementation. And by that time, we should have a better idea of how we're going to proceed into peer-to-peer, into a testnet. But ideally, we would just be iterating upon the Ruby release, which is just a testnet. until most of the other sharding teams figure out what networking sub protocols are going to use, how we're going to work with that. Yes. So yeah, so keep in mind that phases 1 and 2 can be done on a local computer just through the file system. And I think that's the easiest way to get an end-to-end example working.
So we are going to consider phase 1 and 2 as part of Ruby release, right?
Mm-hmm. Yep.
Okay. Yeah, I think the peer-to-peer stuff we can kind of set aside for a little while. Where phase 1 is super minimal. It's kind of exploring how these entities interact with each other, and beyond that, phase 2 is the real chunk of the work. That's the real sharding component. That's what's going to take the most amount of time initially. So, as far as like tagging things, phase 1 can be a tag or release of within the Ruby milestone, but like bigger project, phase 1 and 2 should both be local before we consider like launching into some other bigger testnet.
That is correct. So yeah. So just to recap, we will not be considering peer-to-peer networking for phases 1 and 2. And we want all the other sharding implementation teams to reach consensus on what peer-to-peer we're going to use, because that's critical for the success of this. So yeah, just don't worry about peer-to-peer for now. It's great to keep that in mind and to think about potential implementations, but for now, just local file system interactions work perfectly fine.
Yeah, we should not consider it a requirement, but definitely start working on it if anyone's compelled to.
Yep. So yeah,
just for the transaction pool. So if we're not going to have peer-to-peer, so basically we're going to be locally feeding in the transaction, right? Using Preston's transaction generator.
That's right. And one thing is that we don't even need pending test transactions to be generated, because since there will be no state execution for phase 1, we can just package random data into collations. We can just package the word like Preston, the words Preston into collations, and it wouldn't really matter. The whole idea is just to get this whole crypto economic incentive game between proposals and collators working, and to add information to the shard chains. So even the transaction generator is not a requirement for phase 1, if that makes sense.
Yeah, we really can just use 1 megabyte of random binary data, and it's fine. It doesn't need to serialize or deserialize because there's no execution for this phase. So in terms of generating transactions, that's not going to be part of phase 1 or be part of phase 2.
Correct. Yes.
So it's like a basic framework, just getting it set up. That's it, right?
Yep. Just a basic framework, end-to-end example. And I think that's the key point. I think the approach that we should be taking at Prysmatic is to just think about things pragmatically as how they would work from end to end, and work towards doing that. So my idea for following that approach is that would give us more flexibility in terms of working on individual pieces later on. So think about it this way, right? Like we get a basic skeleton of an end-to-end example working, and then everyone that wants to work on specific items can come in and fill in the blanks or elaborate on things that have already been done, that have already been like minimally done. So say that we have this whole phase 1 interaction done, right? Then maybe Enrique, who's interested in the sharding manager contract, can elaborate more on that. Maybe Nishant, that is interested more in the actual communication of data, can work on that. Terrence, who could be interested in the crypto economics, can elaborate more. So just building up a skeleton for the entire system and being able to work concurrently. The reason for this as well is to prevent blocking of progress. We don't want, like, say for example, the add header function or something to block our entire progress as a team, or we don't want the whole proposal commitment to block our entire progress as a team. We want to get something minimally done through a sprint that then we can build up to be the real thing. And I think that's critical, especially because we're distributed.
I think that we also don't need a transaction pool for phase 1 since it's local, right?
Yes.
So there won't be batching transactions.
Yes, absolutely. We do not need a transaction pool.
but we do need a proposal pool, right?
But we don't necessarily need a proposal pool. The way I'm thinking about it is that we can just save proposals to like into a file in like a directory, in a local directory, and then collators can just
But it still needs a tool to fetch the highest bidder, right? Because you still need a bunch of proposals to see which one has the highest bid, and then select from there.
I mean, we can just save multiple. We can just save multiple files into this folder. Yeah. But yeah, I see what we definitely need a way to filter through these proposals by highest payout. So we can think about how to do that. But the idea is we can just use the file system for that. Once again, this is super minimal, and it's just a way of getting a skeleton working.
You could think about like having a file that each proposal appends a line to the bottom, and then once the collator has selected one, it just erases the file, and then the cycle continues. So phase one is super minimal. Like it's one proposal and one collator. It would be nice to test 2 or more to see that there was some selection of the highest bid being selected. But in terms of like proposal or collator pool, you basically read this file in and then say there are 3 proposals in there, and that you've constructed your pool from that, and you just choose the best one.
Cool. Yeah, I do think it would be really cool to be able to spin up multiple proposers upon like running our system. For collators, it's fine if we just have one. I mean, I would really like to see the whole proposal confirmation game working with multiple people. So I think we can kind of think about that towards the end of the phase 1 implementation.
It should be trivial to add more and more. Sylvan was working on Docker containers, so it would just be like changing a parameter to 2 of these instead of 1, and we should be able to see that pretty easily with some kind of infrastructure like that.
Cool, excellent. One more thing to note is that the sharding manager contract in the previous spec only managed collators, but in this case, the sharding manager contract will be managing both collators and proposers. The reason for this is because when a proposer creates a proposal, they need to deposit their ether into the contract. So I mean, using the contract is an easy way of keeping this ether locked up and making it easy to transfer down the line. Right? So yeah, I definitely recommend you guys become super familiar with the phase 1 spec. Everything is outlined here, as well as the parameters and the methods required in the sharding manager contract. So you guys are going to be able to see the register collator function, deregister functions, the entire like get eligible collator function, and how slashing will work. So in terms of like what's blocking us, the sharding manager contract is one of the things that's is one of the most important things for us to get started on. Enrique is already working on it. But if there are some functions that we don't want to implement now, we can just stub those out or have the Go bindings return something different or whatever. The key thing is we just need to proceed without anything stopping, significantly hindering our progress.
Are we going to share the sharding management contract with the other teams in terms of the API and stuff like that?
Cool. Good question. Yes. So we had a discussion with the other sharding teams, and the idea, it was just discussed verbally, but we're thinking of using the sharding repo on Ethereum. So it's like on GitHub. So Ethereum/sharding as a common ground to share like markdown ideas, proposals, and such, and to have like a single repository for a contract, maybe implemented in Viper, and then for us implemented in Solidity that everyone can agree upon. So that was discussed. Having a single folder, at least for the contract, makes the most sense.
Right.
And I think we're going to push for that to happen, especially because it'll make our lives easier down the line. Additionally, we also spoke with the core Go Ethereum team, the upstream repo, and they mentioned that it's really best for us to figure out how to collaborate earlier rather than later, because they already had certain situations with other projects that they were not able to merge into master. And that's a major problem if we don't figure that out. So it's been great that we've been modularizing our code into a sharding package, because that, there are very few conflicts with upstream in order to merge. So we're currently in the talks with Peter and those guys to receive some sort of privilege where we can have our own sharding module and not have to worry about upstream merging in the future. So we'll keep you guys posted on that. That's still in the works, but it'll make our lives a lot easier moving forward. Cool. Does anyone have any questions before we dive into some specific implementation details of the proposal confirmation games? Cool. Anyone? It can be about anything. All right. Cool. So let's map out, maybe all of you guys can also jump in if you want, but let's map out how the end-to-end system would work, just as a quick informal rundown of the system. So, for step one, the first thing that would happen would be that a user would spin up a collator client, deposit some ETH into the contract, and listen for incoming block headers, right? So, concurrently, a proposer client would spin up and begin processing transactions into collation bodies and collation headers. So what would happen after this? So basically the user would be selected. The user would be selected as a collator in a certain shard during a specific period during a specified look-ahead period, right? So the look-ahead period is going to be like a 5 minutes notice. It should be 5 periods ahead. So that's around 25 blocks. And we do this so that the user has enough time to prepare a proposal and to be able to add that to the add header function of the sharding manager contract. So a key question here that we had as a team was, okay, why do I need this look ahead period if I can just always be listening, right? Why is this necessary if I can always be ready to propose a collation for the contract?
I can answer that if you want.
Okay.
Yeah, so this is kind of a scalability optimization where, like, sure, you could be listening to all 100 shards and looking at, getting all the traffic from all 100, but if we were to someday go to 1,000 shards, it's just not going to scale. So rather you listen on the contract to see, okay, in 5 periods, what shard do I need to be listening to? And when you say, like, okay, I'm selected for shard 2, then you join the peer-to-peer network for shard 2. You start getting ready, get your things ready, you find your peers, and then when the period comes that you're selected for, you start accepting proposals and proposal bids, and then you play the game, the proposal collator game. So it's really just an optimization so that you don't need to be listening to all shards all the time for a specific event that might happen once or twice a day.
Yep. In our current implementation, there is no look-ahead period. We basically get selected in real time. So, basically when an incoming block header comes in, we check if you're the eligible collator, and then you get selected immediately. We want to make this so that there's a look-ahead period instead. This is super important, and it's not a requirement for phase one, but it's going to be a critical part for security and for optimization. So what's going to happen after you're selected in the look-ahead period, right? So now the collator is selected within 5 periods. But okay, so then the collator would look at all the proposals for the assigned shard. And here's where it gets interesting. So the first thing that the collator would do is that the collator would sort by highest ETH payout. In the spec, this is known as the proposer's bid. Super important terminology here. So he would sort by the highest ETH payout, and keep in mind that the collator only has access to the collation header. Cool. So the collator, after the collator looks at all the different proposals, this step is important, and I think it wasn't very clear from our previous discussions. But the collator publishes something called a commitment. Which is a signed message that details the proposals the collator looked at and will accept if the corresponding collation body is published as well.
This is an exclusive list. They're claiming they will only accept proposals from this list when the body is published, and that's to keep them from gaming the system and like sort of stealing proposals and then claiming them as their own.
Yes. So it's important to keep. Yeah, this is to give peace of mind to the proposers. Does that make sense? Right? So what's the risk here? The risk here is that, okay, I publish my proposal and I give a deposit to the collators, but I don't have any certainty that collator will accept mine, right? Or the collator could just say that he will, but there's no proof that he actually will. So I could put an effort to publish the body only to be duped in the end, right? However, with this signed message, I basically receive a guarantee as a proposer that, okay, great, if I publish this and I'm the highest payer, then I'll get accepted by the collator, right? Also, what's important of this, so what's important with this is the next step. So essentially the proposer publishes the collation body, right? After looking at the commitment. This can go wrong because the collator might be lazy and they might not actually download the collation body. So collator might not actually download this body and be lazy. This is known as the validators dilemma. And the idea here is that the collator can just like, he'll expect that other people will validate it. It's not really his job. Like he doesn't really care to download the body because it takes up storage, bandwidth, and effort. So here, that's a problem, right? Because as a proposer, this is a problem because as a proposer, I only get paid if I only get paid the transaction fees if available collations were published to the shard chain. So I want to receive a guarantee that the collator will download the body. And the scheme that was come up with to solve this problem is that we give proposers the ability to challenge collators. What does this mean? That means that if I'm a proposer and I'm unsure that a collator will download the body, I can challenge that collator and ask them to release the body. If they fail, they get slashed in the sharding manager contract. Cool. So this eliminates the issue. This eliminates the risk of the fear of not having your collation body downloaded by the collator. Right? So that's essentially the entire scheme at a high level. I just wanted to make sure that everyone was clear on that. And that's the sort of game that we're going to be implementing in our phase 1 spec. Just keep in mind, to understand this better, just keep in mind the incentives each party here has to dupe the other. And you'll realize that this scheme kind of addresses most of the major, well, basically all of the major attacks that are possible. There are still other attacks that are possible that are being investigated, but for now, these are the most important, and this scheme kind of addresses that. So,
I have a quick question. What about the proposer withholds the body? Do we care about that right now?
what if the proposer withholds the body?
And doesn't the collateral?
Yeah, then the collator would not choose that proposal. They would choose the next highest bid where the body has been split.
Yeah, that's why the commitment includes. That's why the commitment includes the proposals that the collator has that will be willing to accept. I'm sorry about that. So, and include multiple, even though only one will be selected in the end, right? So essentially, will be the collator will say, oh, there are 10 proposals in line. If one of you, if the highest bidder doesn't give me the body, then I'll just pick the second one, and here's proof. So obviously, if you're a rational proposer, it doesn't make any sense to not publish it. You're just not going to get anything, and you're going to waste your time. And so so essentially that is the main idea. So after this, what happens, right? So after the collator accepts, so the collator will accept the valid proposal, get the payout. Well, first, the collator would actually add that proposal to the sharding manager contract, add header function. Through this function, the collator will receive the proposer's bid. And actually, there is one important thing that I missed here that I'm going to add right here. So the key thing here is that the collator needs to figure out what the canonical chain is. The collator needs to figure out what the longest valid shard chain is to add a collation header on. So essentially, there's going to be a function in the solidity contract called guessHead. Which implements the fourth choice rule of shard. And the reason why we do this is we're gonna immediately look at the previous 25 blocks. 25 blocks, validate them, figure out the canonical shard chain.
That I think that can be outside the contract, that function.
Okay. Cool. Done through the collator client.
Okay.
Cool. Yes, so that's really important. We will look at the previous 25 blocks, and this process is going to be known as Whineback. You guys will see this in the documentation a lot, but that whole process of looking back to validate the previous headers to make sure that you're not building on the wrong thing is known as Whineback. So after that, the collator will add the header through the add header function and receive the payout, right? So let's what happens at the very end. Everyone in the system gets paid if and only if the collation was added to the canonical chain. The proposal collator game was played out successfully. Potential challenges from the proposer were answered correctly by the collator. And that also collation body in the canonical chain are available, which is basically a corollary of C. And I think that's it's really critical to understand this. The important thing to keep in mind is that collators get paid a collation subsidy by the network, which is essentially the payout that they get for adding something into the shard chain, and get paid the winning proposals bid.
Wait, can you elaborate on subsidy? Where is that defined? I haven't heard that before.
Sure. Let me just look that up. Yeah, I think you're right. We haven't mentioned that. Let me take a look here.
It's 0.001 ether right there.
Yeah, the virtual ether. Yeah, that search thing sucks.
Oh, it's in virtual. Okay, I see.
Right there.
Yep. So it's something that's fixed by the protocol. So essentially, for doing a good job, collators are going to be awarded a currency to do this. So let's talk a little about virtual ETH. I think that's an important concept that we haven't discussed before. So they get paid a collation subsidy in virtual. So what is virtual ETH? So since we're going to be building a new chain, a new blockchain, and it's going to be done through a smart contract, we're not really going to have real ether in the sense in every sense of the word. We're going to be having like a sort of token that will be used for shard chains that is going to be non-fungible with ether in the beginning, like in our sharding system, right? Like the ether that gets paid out isn't really interchangeable for real ether or for real money, because it's not like actual money on the main chain. It's more managed through a contract. So the idea is that in the future, when we have state execution, which we'll get into later, then we will be able to make this virtual ether fungible with ether and such. This is still heavily under the works, so we don't want to give the final word on that. But just wanted to give you guys an idea. If you run across that word, that's kind of the currency that's awarded to people on the shard in the sharding spec. Cool. So collators get paid a collation subsidy and get paid the winning proposals bid. Proposals get nothing in phase one. Why is this the case? Because it's proposers, not proposers. The reason being is that they will be awarded transaction fees from available valid collations in the execution phase. So we can't really give them anything until these transactions are executed by somebody, and you're able to actually determine if they're valid and available and such. So in the meantime, they'll get nothing. So that's not a problem for a local testnet implementation. So we don't have to worry about that. We'll just be running proposal nodes locally at a loss. But down the line, they will be rewarded once we get execution, which we'll discuss a little bit.
This is also virtual ETH, right?
Yeah, that should also be in virtual ETH. That is correct. Once again, if any of this is unclear, make sure to really study this spec because it details all of these terms that I'm using.
I have a question. Proposer also needs to deposit inside the sharding management contract, right?
Yes, that is correct.
And under what condition will that get slashed?
Sure. Let me just take a look because there are two things that they deposit, I believe.
I couldn't figure that out myself.
Cool. Proposals. Yeah, so there are two things. So there's the proposer's bid and the proposer balance.
Yeah.
The proposer balance is basically like a little stake that you need to put in the contract just to participate in the network, right? So it's a small balance. It's just basically for participating in the shard. Okay. I don't think there is a mention of slashing of this balance. Correct me if I'm wrong. The bid, however, it's basically gone forever. Whenever you create a proposal and you submit it, that ether is going to be burned from your balance. So essentially, you would basically lose that forever every time you issue a proposal and it's accepted by the collator. If it is not accepted at all by the collator, meaning if it doesn't pass the whole collator proposal game, then you'll get that back to your balance in the contract.
Got it.
So basically, I have 100 ether. I'm gonna deposit 100 ether as a proposer, and my bids will come out of that balance. Does that make sense?
Yeah, that makes sense.
Cool.
So you could bid like some smaller piece of that. You could say like I have 1,000 ether balance, but I'm only gonna bid 0.5 for this because the fees that I might make, the gas fees I might make, are going to be 0.6. So I would make a little bit off that, and then incentivize the collator to choose me because I'm offering half ether for that.
So that is essentially it for phase one. That is what we would need, and at that point, we would all consider having a skeleton of this system done. So these steps are just what are important to keep in mind, and that's kind of what we'll be implementing. Keep in mind that this interaction, the collator proposal game, will be done through the file system, through like just storing the collation headers and bodies into local files. Yes. So let's go over the next thing we need to discuss. So before we dive into the actual implementation, like plans and who's going to be doing what, I want to discuss a little bit more about the execution stages, because I know that's like pretty unclear. I know you guys might have some questions. I know we had a lot of questions about that. We still do. But the way execution is going to work is that you're going to have nodes in phase two called executors. They will be in charge of downloading state required by transactions, processing them, and then sending the payout, sending the transaction fee payouts to basically to the person to the proposers from phase one, right? Which is why it makes sense in this scheme that proposers would also be executors. Because it just simplifies things in terms of doing the payouts, right? Like if proposers are also executors, it makes it easy for them to just receive the funds themselves instead of having to send them out, figure out who the proposer that created it was, and do all this checking. So the way we can do this is we can do it through a modified EVM. Or we will have to do it through a modified EVM. We can do it through a TrueBit style interactive computation. I don't know if you guys are that familiar with that, but it's like a different computation scheme that's done through crypto economic incentives. It can be done through basically the EVM can be like done through eWASM, which is an Ethereum WebAssembly, which basically means Ethereum flavored WebAssembly, which is a spec that's been heavily in the works to change the EVM to make it a little bit more compatible with the latest developments and in kind of virtual machines. And this is something that there's a lot of work being done on eWASM, and Vitalik has mentioned that he really wants the EVM to be implemented kind of through eWASM instead. And this is something that will happen in the later phases. I know that it's very early and that maybe we're not all very familiar with eWASM, so this can be done down the line. Just keep in mind that phase two executors can have different types of execution processes. And the key thing is that they're going to be rewarded by crypto economics. They're going to be rewarded by crypto economic incentives. So executors will get like probably a payout as well for being the ones that execute the transactions. They're going to be incentives for them to download the state. There are different ways that we can kind of play this game, but just keep in mind that it makes sense that proposers will also be executors in the future. But for phase one, for our implementation, we don't have to worry about executors for now. So just keep that in mind.
Yeah, and the reason the proposers want to to act as a executor also is so that they can ensure that the transactions that they're including will actually execute and be valid, because if they don't, then they won't be awarded those gas fees.
Correct. Okay. So I don't think it's worthwhile for us to discuss the later phases. The purpose of this meeting is mostly to get everyone up to speed and to understand how we're going to proceed with the next few coding sprints, which I think we've reached pretty good consensus on with Preston. So let me see right before we dive into that if there's anything else we want to discuss. Cool. I think we did cover everything. The end-to-end example. We talked about having a single sharding manager contact API, and we discussed a greater sharding roadmap. Cool. So let's discuss how we can actually do this, right? So I'm in favor of having the skeleton approach, where we get this and then fill in the blanks with everyone's strengths. So we should talk about some of our important roles as we build this out, right? Preston, I think you mentioned to me offline that you like being a code reviewer. You enjoy kind of making sure things are in order and that people are doing the right thing. You also don't have the full bandwidth maybe that that I do or Terrence do to be able to code.
So yeah, basically, most importantly for me in this project is I care about the code quality. And yeah, I don't have a whole lot of time this quarter to contribute during the week, so it'll be mostly during the weekend. But during the week, I, of course, have time for code reviews and things like that. So please assign me to anything that you want code reviews on. That's what I'm enjoying right now.
Cool. And yeah, so Enrique, do you want to chat about kind of what you're interested in with this spec and what you've been doing?
Yeah. Okay. I'm doing the contract now, but this week I don't have really a lot of time.
Yeah.
But I think I'm gonna push the contract today. So what I did, but it's a very early work in progress, and so people can contribute to it also. And I don't know much code, but I'm gonna try to do some tests of the in the contract also, and that's it for now.
Cool. Yeah, I think it's important for us to figure out how so that we don't stall on the contract, because so much of this end-to-end spec depends on kind of the contract working. So I think if it's best for you, Enrique, definitely stub out methods and maybe add some commentary on maybe guidelines and how we can get started on them, and then you can just assign certain pieces to different people. So that can be part of your PR, or it can be done. It can be through multiple PRs, however you think would be most efficient for us to finish it concurrently. We just kind of don't want it to be like something that slows the rest of the implementation down. But yeah, no, thank you for letting us know. I know that you're super busy in the next week or 2 weeks. So whatever you can to get something basic up and running, even if it doesn't work yet, I really appreciate that.
Sure.
Cool. So based on the spec, so Sylvan, is Sylvan with us?
Yes,
Oh, okay.
He had to catch a flight.
Oh, okay. Yeah. Okay. So Sylvan, we spoke offline. Sylvan is interested in understanding kind of working a little bit more on the phase 2 spec as well, and understanding how we're going to work on state execution, how we're going to be doing that. He's also happy to contribute with the crypto economic collator proposal game, and to help make that a little bit more robust. Nishant and Terrence, you guys want to talk about what you guys are interested in?
Yeah, for me, I am interested in the collateral proposal game. So I'm more interested in the crypto economical side, and that could translate to coding as well. So that's what I want to work on.
Cool, awesome.
Yeah, so
I know you're working on the P2P spec, so sorry if this kind of
no worries. Yeah, I'll be okay with the proposal client. So since we're not having any transaction pool, I'll just get transaction blob, it's like shifted on to the collator client.
Cool.
Shouldn't be
Awesome.
yeah.
Yeah. So if you can kind of do that part, like packaging things into collations. Yeah, that'd be great. So Terrence wants to do proposal collator games. Nishant wants to create collation objects and process data into blobs. And I think, Nishant, you can kind of work with Preston as a code reviewer as well, because Preston might also want to contribute in serializing transactions, even though it's not a requirement. But I think it'll be interesting to figure out the exact file structure of a collation.
Yeah,
you guys
I've been thinking about serializing data. So when you get to that point, I have a few ideas and things we can talk about.
Cool. And I will be focused on operations, and I'm going to be personally more focused on going to focus more on cranking out code and working with you guys on anything that needs to be done. I think ideally I would want to work closely with Terrence on the proposal collator games, and working with Terrence on the proposal collator interaction. So yeah, Terrence, I'll probably be working with you heavily on kind of working on your PR or on your branch or anything, and kind of working with you to push things to your branch and then get things running on that front. I think we can do some interesting collaboration like that. And then we'll be assigning all of you guys as code reviewers, or whoever wants to take the lead. Really appreciate that. So yeah, update on my end. Outside of figuring this out, I've also been working on kind of getting the word out there for Prysmatic and making sure we have more support. So we also received a grant from Ethereum Community Fund, aside from the Ethereum Foundation grant. So currently working out the logistics for that. We'll give you guys more updates once that's official and public, and we're able to kind of update everyone about it. Yeah, but have been working on getting these people supporting us, getting commits, and making sure we have enough capital to support our efforts. So just been kind of ironing that out. And once we have things confirmed and we have the operational capacity with this, things will move faster, and we'll update you guys, basically. So, yep. Give me a second. Okay. So one more thing. Yes. So speaking about community outreach and stuff like that, let's discuss a little bit more about how we're going to be updating people throughout the community. So, Preston, do you want to chat about maybe the website or biweekly updates or newsletter?
Yeah, so we were just talking about and thinking about different ways we can keep people updated on our status. Of course, we have these YouTube videos that we're working on live streaming, but those may not be frequent enough. Like, I was thinking we could do different mediums, like talking about specific things on Medium or on Reddit, or we actually have an email mailing list on the site. We can send out a blast there for people who are interested. Yeah, just like kind of keeping people, in light of what we're working on and sharing our progress with people. On that note, I was thinking we should look at updating our site to sort of aggregate all these channels. So maybe like some kind of blog, something. I don't know. It's kind of my proposal is should we improve the site? And I don't have any specific ideas, but a lot of like if anyone interested or wants to mention something about how we can make it better, a lot of opportunities there.
Cool. Yeah, so in terms of updating the website, is there anything in particular we're thinking about adding, Preston? Like maybe information about our code, or what were you thinking?
Yeah, I mean, nothing really specific right now. I'm just thinking like we didn't have links to our YouTube channel or Medium or whatever. It's really a basic one page.
Can you guys hear me?
Yeah.
But I cannot hear you. Couldn't hear anything. So. That's okay. It's only me.
Okay.
Yeah. Couldn't hear me earlier.
Okay, cool. So let's see. One more thing is, So we will be releasing, I think, bi-weekly updates. So if anyone's interested in helping out with that, or just kind of, they'll be short. It'll just update us like, hey, Prysmatic is working on the phase 1 spec through the local file system. And, that can be an update like, oh, like, hey, Prysmatic just finished a proposal collator game. Like, here's what we're doing now, and check out our project page. Something basic just to make sure that everyone knows where we are. I think that's one of the things that differentiates us from a lot of the other sharding implementation teams. A lot of them haven't started yet, or just haven't been like really public, or haven't been announcing what they're working on transparently. So I think that's been getting us a lot of great opportunities, and a lot of people have been kind of praising that transparency. So we will be keeping that up. If anyone has thoughts on that or wants to add anything, feel free to let me know or Preston know, and we can work on that together. So so let's chat then about the first sprint. I think I think we already discussed it, but we will be focusing on the end-to-end example. This shouldn't be that many lines of code, to be honest. I think the commitment and the proposal game can get a little bit hairy. But the basic idea of just interacting through the file system, listening for changes from each other, and adding things to the SMC, is not as complex as it seems in the beginning. And I think our first coding sprints will be focused on this. So one of the things that we need to do is we need to clean up our previous GitHub issues on the matter. So let me pull up our repo. We can kind of talk about some of our open issues and our open ticket items. But anyways, we're almost done with the meeting, guys. Sorry I've been keeping you guys for too long. But let me just share my Chrome. All right. Cool. So let's take a look at the open issues right now. So we have the P2P protocol specs proposition. We can keep that open as a question. I think that's, it was tagged as Sapphire. You guys had a discussion about that earlier in the Gitter chat, so that's good. The GPU license text, Terrence, we can solve that by, I'm gonna be asking Peter from the Geth team on this, and we can kind of get this issue, I'll try to get this issue closed ASAP.
Yeah.
Aside from that, the sharding manager contract to license phase 1, I think Enrique is going to be publishing that soon, so he's going to be referencing this issue, and we can close this issue once that's open, and we can just continue the discussion in the PR's description. We do not need a proposal pool. We can maybe push that over to Sapphire, but we can close that issue in the meantime and kind of reopen in the future.
Yep.
For collator client modifications, I'll also revisit this PR. I think this is out of date. Nishant, I think for number 59, proposal client implementation notes, maybe you can just talk about how you're going to be packaging collations into files and saving that into the local file system, and just try to clean up that issue to align with what we just discussed.
Yeah, I'll add something later.
Cool. Preston, for your TX generation doc and markdown, maybe tag this as Sapphire or whatever you see fit.
Yeah.
Let's try to clean up this stuff that might be a little bit out of date. Let's see what else. Also, Terrence, your issue on withdrawing funds to leave the collators pool, that's going to be done through a smart contract. There's a function called deregister collator, so we can kind of close that issue or just mention that somewhere else. And anything else that has to do with execution or checking for gas limits, such as like this number 37 opened by Preston almost a month ago, is definitely out of date because we will not have any state execution. So we'll be cleaning a little bit of this up, and we'll be opening new things to align with the new sprint. So the new sprint will involve getting the skeleton done, and we'll be assigning people accordingly. So I'll be working on that soon after the meeting and starting to assign people and starting to open the key PRs and the key issues associated with this. A few more things. Let's take a look at the PRs. Also, these would need to be modified. We will not be fetching pending transactions anymore. This can be passed to root to Sapphire release. And then Nishant, I think for number 60, which is creating the proposal client interface, simplifying this because this is going to be a multi-PR feature instead of just having it into one giant PR. Try to split that up into maybe just the proposer client, packaging collations and such.
Okay, all right.
Yeah, I think just keeping the scope very narrow of our PRs is really important because one of these things could easily be like the whole project. We don't want to have that all inside of a single PR. So cool. That is it for issues and PRs. We will be cleaning those up soon after that. We have one more ticket item, I believe. So no. So the last thing is, okay, cool. I will be, for immediate action items, I will be assigning everyone as implementers to issues, reviewers, cleaning up the previous stuff, and then we'll obviously always be reachable through Gitter. So if you guys have questions on this or want to understand how to get involved, if there's anyone else listening that is not a contributor yet and wants to contribute, then please don't hesitate to ask. And happy to point you in the right direction, even if some of the issues don't make sense, because a lot of the things that we have are very context sensitive and they have a lot of knowledge built up from the past few months. So if you don't know where to start or don't really understand what the issues entail, then please talk to me or Preston or just mention that directly over the Gitter channel. But that is essentially it, guys. I think we envision maybe like a few coding sprints to get this end-to-end example done. And I think that we all have something valuable to add to the table. So yeah, let's cap off the meeting then. So does anyone want to talk about anything else, bring up any other points, or have any questions?
I have one last question.
Sure.
Is there any sharding project that's also working on phase 1? If yes, can we look at their GitHub repo just to make sure that we're all on the same page?
Yes. So there are a few other teams. Most of them are at the sharding research stage. The only one that I think has already started is PyEVM. However, they had to do a major overhaul of what they're working on. So they started from the execution layer, where we started from the client layer. And if you look at the PyEVM repo, they have their information, but they basically have to restart all over again. So all of their code is out of date, and they need to do a lot to kind of restructure their repo. So no, there aren't any teams, as far as I'm aware, that are as far along or at least have started on this as much as we have. But if you guys come across any of them, please let us know.
Yeah.
I know that they will be starting very soon, so it's important for us to kind of get this phase 1 up and running, and then set the example for others to reach consensus on an implementation. Cool. So yeah, any other questions? Anything else you guys want to talk about? You guys all clear? Once again, we can chat about this on Gitter, but yeah. So thank you all for joining in. We will be proceeding with next steps over GitHub, and you guys will know exactly where to begin, and feel free to add anything that we missed out on. One more thing is that let me think. Pretty sure just trying to think if I missed anything important. Nope, I think that is basically it for phase 1. So, all right, thank you guys, and we will be in touch.
All right. Thanks, everyone.
Yeah, thanks, guys.
All right,
Thanks.
thanks guys.
Bye.
Cool. Thanks, everyone. Take care, guys.
All right, bye.